The Equipex Aster Cerege is based on a new platform for isotope geochemistry located on the campus of the Technopole de l'Arbois in Aix-en-Provence. This project originates from the Cerege laboratory, supervised by 5 founders: Aix-Marseille University, CNRS, IRD, INRA, and the Collège de France. The first equipment is a compact accelerator mass spectrometer called X-MICADAS, which is dedicated to the measurement of carbon-14 in microsamples. It is installed in a brand new building, which also includes facilities to purify carbon compounds before isotopic analysis. The second equipment includes a mass spectrometer with a plasma source, a magnet, and multiple collector of ions. This MC-ICP-MS is complemented by an ultra-clean laboratory for the preparation of samples. The third equipment is a new ion source for the 5 megavolt accelerator called Asterisk. In parallel to many technical development, the 3 spectrometers allowed us to contribute to several scientific projects in fundamental and applied geochemistry. The X-MICADAS spectrometer has an hybrid ion source working with graphite targets and CO2 gas. It is coupled to a gas interface system which is linked to 3 different CO2 sources, a cracker for glass samples, an elemental analyzer for combusting organic matter, and an automated system with wet chemistry for carbonates. Our laboratory is also equipped with a graphitization system directly coupled to an elemental analyzer. The targets are introduced into the ion source using a magazine holding 40 unknown samples, standards and blanks. We developed techniques for cellulose purification in order to analyze wood samples. We also show that carbon-14 is efficiently measured in atmospheric aerosol samples by using the CO2 gas ion source, which can handle microsamples. The development of precise C14 dating of wood allowed us to contribute to the radiocarbon calibration and its implication in geochemistry, geophysics, and astrophysics. For example, our new dataset on subfossil trees from southern France can be compared to equivalent records from New Zealand. We can estimate the inter-hemispheric gradient in carbon-14 during paleoclimatic events. Another project is to quantify the relative contribution of fossil and non-fossil sources of atmospheric aerosols. The outcome is to better understand the sources of these fine particles and to attribute them to natural and anthropogenic processes. For example, the importance of biomass burning and road traffic emissions have been quantified for the Valley of Chamonix and the region of Aix-Marseille in Provence. We also initiated projects on the response of soils to anthropogenic pressures and on their role in climate change.
The second equipment of the Equipex project includes the MC-ICP-MS spectrometer. This facility is equipped with an inductively coupled plasma source, a magnetic mass filter, and a multiple collector system. The ICP source is able to ionize every element in the periodic table, and our new spectrometer allows analyzing a large set of isotopic systems from the classical radiogenic isotopes to non-traditional isotopes. In addition to its versatility, this new generation mass spectrometer presents many advantages. First, it allows large sample throughput as well as to analyze very small samples difficult to measure with previous technique. Possible contamination of samples during chemical procedures is a major challenge. For this reason, we also constructed an ultra-clean unit dedicated to the chemical preparation and purification from natural samples. One of our main scientific objectives is to carry out specific development in uranium-thorium and uranium-lead geochronology. We are pushing back the limit in terms of precision and accuracy of these two dating methods. As an example, we are now able to date carbonate samples by using uranium-lead method. This broadens our expertise in uranium series geochronology, as the uranium-lead method can be used for ages beyond 500,000 years. That is the limit of uranium-thorium dating.
The The third main equipment of the project is the new ion source, which has been developed and is still evolving in close collaboration with the constructor company. This ion source, with a wheel of 200 targets, has been connected to the front line of the 5 MV Aster accelerator. The new ion source allows increasing by 1 order of magnitude the negative currents and therefore the number of events detected from the targets. Because the most difficult element to be ionized is aluminium-26, we concentrated first on optimizing its detection using the new ion source. The cosmogenic isotopes beryllium-10, chlorine-36 and aluminum-26 are crucial and complementary to quantify processes that affect and model the Earth's surface. One project is to study the spatial and temporal evolution of the relief in geomorphology. Another project is to reconstruct the variations of the intensity of the Earth's magnetic field over the past millions of years. We also dated major sites studied in paleoanthropology. For example, we dated the sedimentary layer, including Tumai at 7.3 millions of years. Using chlorine-36, we established the closure of the Chauvet cave at least 24,000 of years ago. We are thus contributing to the quest of our origins.